The Earth's atmosphere is full of gases and particles that scatter sunlight in all directions. Blue light is scattered more than other colors because it travels at shorter, smaller rays. Because of this, most of the time we see a blue sky. If you've ever wondered why the sky is blue, you're not alone. Why is the sky red? Might have been a common question if you saw a stunning sunset or sunrise. You might think that the reason why the sky is blue are as obvious as the color itself. That is not the case. Why blue of all the colors in the rainbow? Isn't it possible that a sky could be green? Is it yellow? Rainbows can also include various shades of blue and violet, as well as orange, yellow, red, and everything in between. The sun's white light contains all the colors of the rainbow. When we look at a rainbow, we see all of those colors. A sunlit raindrop acts as a small prism, bending and separating light into its various colors. Why are there so many colors? The light you see is just one tiny bit of all the kinds of light energy beaming around the universe and around you. Light energy travels in waves, just like the ocean currents. The wavelength or range of wavelengths is what distinguishes one type of light from another. The wavelengths that are visible to our eyes are included in the category of visible light. We see red in the farthest reaches of our visual spectrum. The shortest wavelengths we can see appears blue or violet to us, while the wavelength of a blue or violet light is 400 nanometers, and that of a red light wave is 750 nanometers. A nanometer is 1 billionth of a meter. These visible light wavelengths, on the other hand, are incredibly small in comparison. It's bent like a prism. Our eyes receive a large portion of the reddish, yellowish, green light wavelengths that are mixed together and nearly white as they enter Earth's atmosphere as they shine down on us from above. It is precisely the right size of blue and violet waves to hit and bounce off the molecules of gas that are present in the atmosphere. Blue and violet waves become dispersed in all directions as a result, making them visible to the naked eye. The rest of the spectrum tends to blend into one another, so it stays white. In other words, what happens to all the wavelengths that aren't blue? They appear white because they haven't been dispersed by the atmosphere. The sky appears blue because of the abundance of scattered violet and blue light. How does the violet end up? The upper atmosphere absorbs some of the violet light. Our eyes, on the other hand, aren't as sensitive to violet as blue. The sky turns a paler shade of blue or even white as it approaches the horizon. Like and subscribe